This is Dr. C. Vidyarani, Assistant Professor, Department of Chemistry PG, V.V. Vanyaperumal College, Paruman, Virudhunagar. Let us discuss on the title Nanomaterials and Its Types. What is meant by nanomaterial? Before knowing that nanomaterial, we have to know that word. What is nano? The meaning for the word nano. Actually, it is a word coined from Greek. Meaning is very small or dwarf. That means it is 10 power minus 9 meter, or we can say it is 1 billionth of meter. So these nanoparticles are that much smaller particles, and its size ranges from 1 to 100 nanometer in its size. Okay, due to this smaller size, it exhibits different physical and chemical properties. It can vary its properties. Due to this change in property, it shows application in various fields. Okay, so actually this material or nanotechnology, the concept is introduced by the scientist Richard Feynman. Actually, he is a physicist. He gave a famous lecture entitled "There is plenty of rooms at the bottom" in a lecture at American Physical Society at California Institute of Technology on 26th December 1959. And in his talk, he suggested there are number of possible ways to arrange the atoms. So due to that arrangement, it shows changes in its properties and having different applications in various fields. Actually, this nanotechnology, it is popularized due to the invention of scanning tunneling microscope and fullerenes. Okay, let us define the word nanomaterials. So what is nanomaterials? These nanomaterials, how we can say this means, it should have minimum one external dimension measuring, that is 1 to 100 nanometer. One of its dimension, it should be in the range of 1 to 100 nanometers. Those materials are termed as nanomaterials. An example for these nanomaterials are carbon nanotubes or carbon nanoparticles. We can say metal rubbers, quantum dots, nanopores. All these are nanomaterials. And we are going to see about the different types of nanomaterials. So basically they are classified under 4 kinds. Those are carbon based nanomaterials, metal based nanomaterials, dendrimers, nanocomposites. So let us see one by one. These carbon based nanomaterials are otherwise termed as organic based nanomaterials. Okay, metal based nanomaterials, they are otherwise termed as inorganic based nanomaterials. And the third one, dendrimers, they are otherwise called as organic. These also comes under organic based nanomaterials, but it is having polymeric structure, macro structures. So dendrimers are organic based nanomaterials. And the fourth type, nanocomposite. Okay, we will discuss it elaborately. The first type, carbon based nanomaterials. These carbon based nanomaterials, they are initially they are produced in the form of fullerenes, carbon nanotubes and buckyballs. So these are some of the types of nanomaterials based on the structural constraint. So 3 types we have shown here. The first one, it is based on the carbon based nanomaterials. So for that carbon based nanomaterials, 4 examples quoted here. So CNT nothing but carbon nanotubes. Second example, graphenes, and third one is fullerene. Fourth one is carbon dots. And the second type of nanomaterial classification, organic nanomaterials. So under these organic nanomaterials, few examples quoted here: liposomers, dendrimers, some hybrid nanomaterials and polymers. And for third one, inorganic nanomaterials, they are classified under 2 categories: metals and metal oxide nanomaterials. So all these are the different types of nanomaterials based on the structural constraint. Let us see this carbon based nanomaterials. So these again classified into 2 categories based on the shape of the structure. The carbon based nanomaterials, it's a difference in shape. For example, it forms a hollow sphere. Sometimes it may exist as a hollow sphere, or sometimes it may exist as a cylindrical form. So if it is present or occurred as a hollow sphere, ellipsoid, means they are termed as fullerenes. Fullerenes are nothing but the carbon based nanomaterials having spherical shaped structure, and it is having minimum, it should have 60 atoms of carbon in its structure. And the cylindrical form of carbon nanomaterials are called as nanotubes, nanorods and nanowires. And it shows various application in various fields. the potential or important applications I have coded here. It is used for the improvement of films and coating for stronger and lighter materials, and also show applications in electronics. So here I have coded some examples of carbon based materials with its structure. So first is the diamond. You see the shape and structure. Fullerenes, it is totally spherical in shape. Carbon nano tubes, it is somewhat cylindrical. It is spherical. Fullerenes is spherical shape. Carbon nanotube is a tube shape. And graphite, it is in the form of sheet. Graphene, next graphene oxide, and carbon dots. Graphene oxides, you see the structure, it is bonded with some oxides here. So we are saying this as a graphene oxides, whereas graphene and graphite, they are having only carbon in its structure. And carbon dot, here also it is having different functional groups, hydroxyl groups, acid groups, all these are attached. So based on the different functional groups and attachment, we are having different types of these carbon based nanomaterials. Let's see the application of carbon based materials. So these plays important role in biosensors, especially for elimination of pollution. This biosensors plays an important role to control the pollutant in air or water. It plays an important role. Next one, it is also useful to detect the hazardous material present in the food, and also plays an important role in pharmaceutical products, gene and drug delivery. So these carbon nano materials show a wide application in medicine field. They are also used in tissue regeneration and gene therapy. Okay. Next, second type, metal based nanomaterials. So metal based, the name itself having the meaning. So its structure contains the metals or the elements. It's made by individual atoms or group of numerous atom in its structure. So metals, we know either it may be silver, gold, platinum. So like that, these metal based nanomaterials are composed of different metals. So I have coded some examples here. So it includes quantum dots, nano gold, nano silver, and metal oxides like titanium dioxide. Apart from that, some of the elemental metals I have coded: silver, copper, gold, titanium, platinum, zinc, magnesium, iron, and other aluminate nanoparticles. Okay, so these metal based nanoparticles, they also plays a vital role. So it is used in biomedical fields. As metals ion, they are very essential for the living organism. So it plays a vital role in biomedical field. Especially it plays important role, or it work against the virus particle, because the particle size of a virus, they ranges from 10 to 100 nanometer. Our nanoparticles, they are sized from 1 to 100 nanometers. So it is possible for our nanomaterials what we synthesize to diffuse on the surface of the virus particles and may distract the activity of the viruses. So we can say this metal nanoparticles plays a vital role in biomedical field, and also it enhances the surface activity. It enhances the surface activity in the metal, especially in nano sized. Okay, let us see on the third type. This is nano composites. So composite, the meaning for this composite, it is a mixture. So it's a mixed form of the nanomaterials. One type of nanomaterial is mixed with another form of nanomaterial. Due to this mixing, it improves its property, or it may enhance the property of a product what we are producing the nano size. So this composite combines nanomaterial with another nanoparticles, or with either larger or bulk type of materials. So by doing this, it will improve the properties. I have coded the properties like mechanical, thermal, barrier, and flame retardant properties. So what are the example of these nano composites? What are the mixed form of the nano composites? I have listed some examples. First one is polymer and ceramic nano composite. These can be mixed to produce a new type of nano composite. Second, the mixture of inorganic material with organic polymer nano composite, or you can say that as a clusters. So inorganic and organic polymer nano composites. Third type is bacterial cellulose or hydroxyapatite nano composite. It is another type of mixture. So three different types of mixed nano composite I have coded. Then what are the properties enhanced by mixing up these nanomaterials? So I listed the different properties here. So first one is mechanical property. So it enhances the strength, modulus and dimensional stability of the material what we are synthesizing as a nanomaterial. And next it decreases the permeability to gases, water and hydrocarbons. And also it improves the thermal stability and heat distortion temperature. And also it reduces the smoke emission. It has also work against the chemicals, or we can say it as a chemical resistant material. And also it improve the surface properties. So like that it enhance different physical properties of the nanomaterial what we have synthesized. Let us see the fourth type, dendrimers. Actually dendrimers, it is a polymeric structure. It's a branched chain structure. So these nanomaterials are nano-sized polymers built from branched units. Its structure, it look like here you see the structure. So it is a branched, like a tree, it forms the branches. So we are seeing this as a dendrimers. It is a branched structure polymer. So the surface of the dendrimer, it is having numerous chain ends. You see this structure. So numerous chain ends are present. Numerous chain ends are present in its structure, and it plays the important role, a vital role in the medicinal field. Okay, to perform specific chemical functions are performed due to this form of structural unit. You see this structure. So different chains or branches they are observing in the structure. So this also is this type of structural unit is also important to enhance the catalytical property or catalytical activity of the material what we are synthesizing. So these structures are having three-dimensional dendrimers containing interior portion is a cavity. So this cavity is helpful to deliver the drug. So it acts as a drug delivery. In medicinal field it is used to deliver the drug. So the three-dimensional dendrimers, it contains interior cavities into which other molecule be placed, and it is useful for the drug delivery. So it is a very important vital role played by the dendrimers. Next, let us say some of the example for this dendrimers. So polypropylene imine, or you can shortly say that as PPI, poly-L-lysine, or you can say that as PLL, and triazine based dendrimers. So these three are few of the examples I have coded here for dendrimers. And what are the application of these dendrimers? So list of applications I have coded. It is having maximum application in the medicine field. So it is used as an anti-cancer drug, and it is used for drug delivery and transdermal drug delivery, gene delivery. Dendrimers are having magnetic resonance imaging contact edges, and dendrimers are also used as sensors and also used for enhancing the solubility properties. So like this, by changing its structural constraint, it plays a vital role in different fields. Thank you.